So the other two pieces of the interface here that are going to matter more for us are going to be this file, right? This is just a text editor. It's where I can write code. It's where I can run code. And then over here is our console. And that's more where any sort of output we might run into is going to show up. If our code gives us any output, we can usually see it over there. All right, so we're going to end up, again, writing in one place and really doing most of our editing, most of our seeing what happened kind of over here. All right, this is just like writing a text file basically in, Microsoft Word or whatever other program you use. We need both of these to work to see if everything is hooked up and working correctly. So I'm going to first just run a line of code to make sure everything's working correctly. We'll talk afterwards kind of about what we're doing. So to start out with, I'll write my first little line of code. This technically isn't a working line of Python code here in many ways. This is a comment. All right, you can see it shows up gray on line 1 here. And if you've noticed, right, I made an indent to a new line. Code files are actually usually numbered by line. That's how code is written and how it's referenced. All right, so generally speaking, code is sort of numerically aligned, starting at 1, going all the way to whatever line we need. This is called a comment, though. It's prefixed with, as we see, the pound sign. And that just means that we won't run this ever, right? This is just annotation for visual reasons for people who might look at or read the code file if we want to. Again, feel free to send either questions in the chat, which is ephemeral and will only last for the next hour or so, or to the Discord invite link I sent if you would like to ask any questions between sessions or later. You have the ability to, again, jump in there just in case, right? It's free. No need to actually contact us or not. Again, it's a good forum to ask questions. So generally speaking, and we have a comment, right? Python, we'll ignore this. And when I say Python, what I really mean is the program Python, which is the Python interpreter. Technically, this is just any old text file. There's nothing really special about a Python file except its extension and the fact that I happen to write it in Python, right? Some sort of nice, stylistic convention we came up with for how our text or really our code is supposed to be structured. But there's a program, Python, where when I click run, it will start up, it will read my whole text file and essentially do what it says. So when I click run, that'll happen, right? If we see my console change to give me whatever output, there was no output because nothing happened. So I have as a comment, but Python did technically start up, read my file, and then do what it said, which was just nothing. Again, to fully make sure this works, I'm going to quickly invoke a function built into Python called print. And I'll click run, and we'll see that my output over here in my console changed, which means I'm going to assume that this did, in fact, work. All right. As I'm sure we can gather, the print function, right, without knowing what a function is or much about programming specifically, simply takes the input that you give it and shows it to you over in your console. And this is how we're primarily going to test our code and see how it works throughout, at least today, is by doing things, manipulating, various values in our computer's memory, and then visually showing ourselves that output over here. So now that we know our setup works, we can talk a little bit about Python and coding in general. We're going to start with what might be one of the most fundamental, I guess, concepts in coding, which is going to be this concept of assignment. What assignment is, it looks like this. And what I'm really doing here is just saying we're going to take some value and we're going to give it a name. Right, and the value is always going to be the thing on the right. This could end up being some complicated mathematical expression too. So instead of 8, it could be like, 8 plus 6, right? Or any large math you want. Whatever this is ultimately going to get stored in this name on the left. All right, either side of this operator, which we sort of know as the equals sign. I'm going to not call it that anymore. This is the assignment operator in Python, right? Its whole job is to take the thing on the right and put it inside the name on the left, and that's it. Why we do this obviously isn't super apparent yet, right? Greg, this seems like a lot of work when I could just type out 8, which is a lot easier. It's actually a lot less characters too than example underscore variable, but we'll see this, later and throughout our writing some Python and see what, the utility here. I'm going to add another comment here too. You can add comments at the beginning of a line. You can also add comments after code at the end of a line. Either works to annotate your code if you want. This is here referencing the line to the left, right? 8 is an integer. So what this is saying is 8 is basically one type of one value that we can capture and represent in Python. In Python, we have what we call data types, as in any other programming language, that we use to sort of show us or reference, different values, right, that we might think of in English. Things like 8 or 12 or your name, right? We have different data types that Python can use to store and interact with or represent different types of data. We might think of 8, 8 is a number, right, which is fair. Technically, Python is 2 types of number we're going to talk about. The first is the integer, right? If you remember back to math class, at some level, an integer is just a number with no decimal, right? So 8 is an integer, 40 is an integer, 206 is an integer, 8.2 is not an integer. Right, so it's sort of the most basic type of number we have. We now have a choice. Anytime we want to use the number 8, we can refer to 8, right? Just type out 8 directly. The green shows us it's an integer. It's a different highlighted color. Or we can reference its new name. So if I were to print example underscore variable, we should get back not its name, but the value it references, right? 8. So we can now use this name to refer to 8 wherever we would like to, right? Wherever we would sort of like to, interact with or reference our 8. So that's all we need to see for the moment for an integer. We'll go more into integers and what they do a little bit later. But there is technically a second type of number, right, that I kind of alluded to as well. It's called the float, or the floating point number. Right, and here's one example of it. Again, we have a decimal. 8.0, technically a float, not an integer, even though the 0 doesn't, even though these are basically equivalent in terms of value, this is a different type to Python, right? 8.0 is a float, or floating point number, as they're sometimes referred to in sort of like full, by their full name. I'll move the console over just so we can see everything on one line so far. If we look, we can still, just trying to spell these correctly. We can show them both to us in our console if we so desire. Right, and they, according to print, they behave relatively the way we would expect, right? We see 8, we see 8.0. But again, we can take both of these new names we've given them and do stuff with them, right? So these are the first two data types we've seen, right? Easy representations we can use of a number, right? Integer and float, because otherwise Python doesn't really care like what the difference is between, a float or an integer or text or anything else, right? Just sees like switches in your computer. These are obviously easy data types, right? We can think of this like, yeah, that exists, Greg. Of course, we need numbers, which is fair. The next data type we'll see is also relatively straightforward, right? We've seen this all the time. This is called the string. As we saw, I used a string earlier, actually, right? In this first print statement, we just hadn't talked about them, so I didn't really refer to it as such. But this literally, as it says, is a string, right? A string being the data type we use to refer to like arbitrary text. A string is defined, right? It's a collection of characters in order, starting with the first, ending with the last. So this string is specifically, right, always going to start with a lowercase t, end with a lowercase g, right? Otherwise, you'd lose meaning and some actual value for it. And as we can see, strings are denoted using an open quote and a closed quote, and everything between those two quotes is the string. Right, we can also create strings with a single quote as well. I used a double quote here. You can use a single quote if you want. The only important thing to remember here is that if you open with one kind of quote, you must end the string with the same kind of quote. All right, so this is, this one has double quotes, this has single quotes. Neither one is really that different. People usually adopt one they prefer and then use it partly just to, not have any issues with using the different types of quote in the same string and having weird errors in your code. I personally use double quotes most often just because they're a little bigger, a little easier to see that they're there. The single quote can kind of hide occasionally, but both of them are good. People love both of them. Whichever one comes more naturally to you is the one you should probably use. So in addition to strings, right, we've thought of text before, obviously. Representing text can get pretty obvious, right? We need to represent things like names, addresses, phone numbers, whatever, right? We need a way we can store text in Python, maybe manipulate it, process it, do something with it. The string is our, again, text representation in Python. There are two other types of data type we'll go over today that are a little bit weirder. If you don't come from any sort of programming backgrounds, that are a little bit less obvious to many people. First, the idea of the Boolean, right? These Boolean values, and a bool in Python has only two different options of value. They're going to be either true or false. All right, so these are the two Booleans in Python. Technically, they must always be capital T true and capital F false. Other languages use lowercase letters. Sometimes those will not work in Python. Those will just be a weird error. But we have Booleans to represent sort of these concepts of true and false. If that's a little strange to you, right? Why, Greg, might we need these hyper-specific types for like the concept of true and false? That's fair. We'll see a little bit later why they exist, and it will make a little bit more sense. For now, our code is going to need a way to really represent the outcome of some different operations or comparisons. So it has sort of this built-in true-false Boolean type. But for now, just know, right, we have capital T true, capital F false. Again, they highlight differently, right, than a variable name, right? They're blue, which in REPL just shows us, right, we've correctly spelled them and there's something special built into Python. There's one last type that we're going to touch on today. There's many other types in Python. There is one last little data type that is worth knowing for today. We'll touch other data types later, which is the none type. We can think of it kind of like it's sort of similar to a Boolean, I guess, and that it's like a weird sort of esoteric static value, but this is the none type, which unlike true or false or something, is really going to represent sort of the absence of a value or the absence of data while still technically having a value. All right, so we have none. We'll see it used a few times and it will make more sense later, but I'm going to introduce them all together just to do it. For now, just know that we also have capital N none, which Python sometimes uses as like a placeholder. Once we know that it does that, we can take advantage of that, and check for its value or something in the future. For now, we're going to back up, though, from some of these types that are a little bit weird. Focus on really what we can do with these original two types, right? Or three types, right? The two numerical types and then the strings, right? Integers, floats, and strings. Obviously, with integers and floats, it should be no surprise to people that we can perform mathematical operations if we need to, right? So Python has mathematical. Fortunately, Python does not spell check for you. Mathematical operators, these are basically what we'd expect as we use Python. So mathematical operators are basically going to be the normal math operations we know and love from when we took math in school. And the operators, right, the symbols for them are largely the same. For example, we have addition, right? We can use the plus sign, right, or the addition operator in Python. We can perform subtraction. We can perform multiplication. We can perform division. And we can perform exponentiation, right? Raising a number to a specific power if we so desire. Subtraction is the dash or the hyphen, whatever we might want. Same as we would use in math. It's worth noting that while I've said, right, repeatedly, integers and floats are technically separate types in Python, Python doesn't really care in terms of math. So you can happily perform mathematical operations between integers and floats. Python will treat them as if they're the same and pretty much always give you a float in response. All right, so we can put either of these as a float either side of the operator and we get a float in response, but otherwise the math comes out exactly as we'd expect. For multiplication, right, we have the asterisk, right, the shift 8 on a normal, at least American keyboard. And for division, we have a forward slash, right? A single forward slash. It's worth noting here, right, that no matter what, this is going to give us back a floating point number, as 12 divided by 9, right, does not divide evenly. So we will, even though we have two integers, we'll get back a floating point number, a float, as our output. All right, we won't just lose the position and round automatically. We'll get back the real value. Lastly, for exponentiation, right, raising a number to a specific power. If you remember from school, usually we would use this symbol, right, the upward facing caret in Python, this is actually reserved for different operations that we're not going to get into in this course. Instead, for exponentiation, we'll use double asterisks. This is 12 raised to the 9th power. And we ultimately get back, let's see, and then division works. Right, we should hopefully get back three things, right? We get 12 plus 9 gives us 21, right? 12 minus 9.0 gives us the float 3.0. And finally, division gives us, right, 1.3, but repeating. So this will give us back a long repeating floating point number. We got one question in the chat. Does Python have a mod? Yes, we're going to get to that. The other division operations, the other two we're going to cover in 1 second, Marcus. So bear with me for like 45 seconds. As Marcus just elegantly segued me. We do have, in addition, two slightly less often used division operations that not that you didn't necessarily see them in math, but they're used much more commonly in code than they usually would be outside of code. So we have two more common division, less common division operations. One of them, my long variable name would tell you, is called either floor or integer division, depending on who you ask. Both are correct. Again, it just depends on the actual person you are talking to, right? Some prefer to say floor, some prefer to say integer. I personally use floor more often, but whichever one you like is fine. So the operator for this, obviously being a different kind of division operator, is not going to be a single forward slash. It's going to be a double forward slash. Does anyone know exactly what floor or integer division does? The name will help if you think about it. So integer division will essentially ignore the remainder. So if we have, for example, 12 floor divided by 9, we will ultimately end up with not 1.3, but any guesses as to what we're going to get printed on line from line 34? What number? We're getting a few ones, right? Correct. We're going to get 1 back, right? So it's only the whole number of times that one number will go into the other, right? 9 goes into 12 once with 3 left over. The other half of the division operation then is modulus division, which we perform with a Python a percent sign, right? This is the modulus division operator. If I run this, right, this will also give us back 1. Because if we divide 37 by 2, we get a remainder of 1, right? There's 1 left over. 2 goes into 37 18 times with 1 left over, right? So we ignore the number, we just keep the remainder instead, right? If I change this, so we have 12 and 9 from above, we ultimately get the 2 halves of division, right? 12 goes into 9 once with 3 left over. All right, and again, these operations are a little less common in day-to-day life, but they are extremely useful in programming. They're used relatively often, so it's worth seeing their operators right now. But again, this is a double forward slash, and this is the percent sign for the other 2 division operations. So cool. In addition, does anyone have any questions quite yet about mathematical operators? Awesome, cool. So in addition, talking about math, it's worth mentioning that in Python, we do follow the normal order of operations as math would. So for example, this statement, what is this statement going to give us as an output from line 37? Any ideas? 4 plus 3 times 2. So we got 2 that's saying 10. Any other guesses? I would say 10. Yeah, so again, we follow order of operations, right? Multiplication first, then addition, right? So we do this operation, then we add the rest. 3 times 2 is 6, plus 4 is 10. So just like in math, if we want to group stuff around, we can using parentheses, right? This will behave as we might have wanted it to, right? This will give us 14, right? 4 plus 3 is 7 times 2 is 14. So we can explicitly group expressions using parentheses if we want in Python. Cool. Again, we're performing all these operations with, right here with integers and floats, but theoretically, obviously the operators work just as well with variable names that are references to numbers, right? If we have, a equals 9 and b equals 90, right? Printing a plus b is the same as printing 9 plus 90, right? These can be used basically the same. All right, so this is, again, a is, as far as Python is concerned, 9, b is 90. We should get the same output here, right? 99 that we would expect. So anything I've been doing with typing out a value is something we could do with referencing a name instead. In addition to math, Python has a bunch of built-in operators as well for comparison. And a lot of these are also as we might expect. We have greater than, we have less than, we have less than or equal to. We have greater than or equal to as well. So we can use any of these operators to compare two values. If you haven't noticed by now, right, Python, in terms of how we name things, right, what sort of our constraints are, Python prefers, it doesn't actually require, but it prefers that we use what's called snake case, right? We use lowercase words separated by underscores. Some other languages use different naming conventions where you, in JavaScript, you might use camel case, right? Where you have a lowercase word and then you title case every subsequent word like this. Python isn't like that. Python uses entirely lowercase letters if possible. If we use capital letters, it usually implies that we're dealing with a class, which isn't something we'll really get to in this course, but there is a meaning there, so we try to avoid it if possible. So anyway, greater than, right? The operator is, as you'd expect, it's the greater than sign, right? The, I guess the rightward facing sideways caret, if you want to call it something else with a angled bracket. Less than is the same idea, right? So less than 2. Less than or equal to is simply a less than sign with an equal sign attached to it. And finally, greater than or equal to is the same idea, right? 3 greater than or equal to 2. So this is now where we'll start seeing a little bit of the utility of Boolean values, all right? right now these aren't going to give us a number back, right? 3 greater than 2 isn't like 7 or 3 or something weird. Instead, the way Python represents these is with a Boolean, right? True or false, which kind of makes sense if you think that this is really a true or false question or a true or false statement, right? Is 3 greater than 2? Yeah. Right, or in Python, not yeah, but true. Right, we get obviously 1 true, 1 false. 3 is greater than 2. 3 is not less than 2, right? So this gives us back true. This gives us back false. And from there, we should, we can start using Booleans to get the outcome of a comparison like this, right? To narrow down some value from that. So in addition to, these comparison operators, it's worth looking at equality as well, right? Equal to and not equal to in Python. Someone in the chat saying, is anyone else's screen frozen? Mine's not. Someone could throw Alex a message in there just so he knows, though. That would be great. Also good for me to know, just in case. Cool, but I'm assuming that it's not a me problem then, which is good for my sanity, at least. Thank you, folks, for weighing in. Otherwise, for equality or the inequality, we can use 2 additional operators. Obviously, what we would prefer in Python would probably be to use the equals sign. That's not the case, right? This has been co-opted already as the assignment operator right here, in fact. So in Python, for equality, we use 2 equal signs tacked together, right? That becomes the equality operator. And then not equal to, we can use exclamation point followed by the equals sign. This could be our not equals to operator. No worries, Alex. Hopefully it'll be stable when you get back. Cool. So now we have 3, in 3.0, right? Which does beg a quick question for me to pose to the group real quick. What do we think the outcomes of these 2 things are? Do we think line 51 is going to give us back true or false or something completely different? Any ideas? So we got 1 saying true. We got 1 saying 51. So we got a bunch of people saying true. One that says 52 should be true. All right, so we're going to print this. And we'll get line 51 is true, right? Python doesn't really care if 3 or 3.0 are integers and floats technically, as long as this doesn't change to be something new and fun. They're considered equal as far as Python is concerned in value. Obviously, yes, there is technically a precision difference here, right? 3.0 is technically a more precise version of 3 or something. But to Python, that doesn't matter in terms of checking the equality, right? 3 and 3.0 are considered to be equal. So this will be true, this will be false. Again, if there was like a 1, right, 3.1, that is not the case. These are different values, right? Because 3 does not represent the value 3.1. It just doesn't. So that's a good start, at least, to the other 2 comparison operators, right? For equality, I'll add a quick comment here so we can see, right? This is true. In addition, we can use many of these operators, not just with integers and floats, but we can use them with other types like strings. So let's try something else. So if we look carefully, without running it on your own, I guess, does anyone, what do we think? Is this string on the left going to be equal or not equal to the string on the right? And what value am I going to get back from the print function on line 56? Any ideas? So we got a few people weighing in, claiming it's going to be true. String not equal to capital S capital T string. So for argument's sake, right, we're saying true, which means that these two things are not equal to each other, right? So this string is not equal to this string. Any takers? Anyone think that actually, Greg, these are equal to each other? Seems no one does, which is fair because these are not equal, right? These characters are different. As far as your computer is concerned, lowercase and capital T are like just different characters, right? These are fundamentally different strings. So this is not true, right? But we can still compare two strings to see, you know, if their characters are the same, if their characters are not the same, for example, in terms of equality. Worth noting in Python, we're not really going to go into it, but technically these comparison operators, greater than and less than, do work with strings. The way they work is just kind of weird. This is really evaluating whether or not they're like their Unicode character values are greater than or less than each other, sort of like sorting or alphabetizing, but it's a weird convention that we don't really, or it's a weird behavior we won't get into, and that is less practical than many other built-in ways to do it that are much easier on the eye and easier to understand. But technically, right, these aren't errors, they will work. In addition, some of these other mathematical operators also work with strings. Specifically, two of them do. So for example, we may have two strings. We can actually use what we thought of as the addition operator, but with strings, it becomes the concatenation operator. And this will simply take two strings, right, one on the left, one on the right, and just stick them together. All right, so we take this is space, add this name to it, and we get this is example. All right, we get one string out of these two different strings. So some of these operators do perform double duty in terms of you know, having functionality for different types depending on what we need to do, which kind of makes sense, right? There's so many keys on the keyboard. We can't have a unique different operator for everything without, you know, needing to do things like this for operators, which would make no sense. So in addition to concatenation, there is also the repetition operator in Python, which would be, again, not the plus sign, right? Not what we think of as the plus sign, but instead the asterisk. All right, these are the repetition operator will take a string and it will take some integer and it will act upon the string. It will return a copy of the string repeated that many times. All right, so you don't want to guess what we get from this expression here. You just get ABC, right, repeated 4 times and concatenated together. So we get one long string that's just 4 times the original. So in addition to these operators in Python, there are also a bunch of built-in functions that we can use if we want to change the type of some value, right? To sort of typecast something from one type to another. So we might have the ability to, change type, but change type between values that we as people might see as, being similar. Python has a bunch of constructor functions built in for each of the types we've seen so far that will take an argument and try to convert it to a different type. So for example, if we create an int, right, this is an integer, it's 3. We can use the built-in float function. And for now, we'll go into functions at a later point, a little more in depth. For now, just think of a function as a reusable bit of code, right? We can call it or invoke it with parentheses, and we give it an input. It gives us back some output. So here I will give it our int 3 as an input, and it will return, right, some floating point representation of 3 in an ideal world. This is a helpful function that will take its input, whatever that is, and convert it to a float. So as we see now from line 69, we get float 3.0. All right, so this has actually been converted and changed types from 3 to 3.0, right, from integer to float. This is a little less useful, right? Python treats them pretty much the same anyway. If we want, we can also convert strings to floats if we really want to. Right, so we can take any string that is a valid float. We can't take like Greg and make it a float. That makes no sense. You'll get an error. We can get back the floating point number 3.1. Now in our console, this looks the same as if it were a string, right? So we don't really have an easy way to, from this line right here, figure out what's going on. But if we want, we can pull some other functionality out of Python itself, just like we've done with float and with print and all these operators. We can pull another function out of Python for now, which is the type function. The type function takes an input, gives us back a string telling us what Python type the input is. If we print this, right, as we're just printing the output of this function, we will get back, right, it says class float, which means we did in fact get back a floating point number. This has changed from a string into a float now, even though we can't visually see it. There are additional functions here we're not going to go into right now. There's the string function str, which takes an input and converts it to a string. There's also an int function, which converts its input to the integer type. If obviously, like float, right, pretty much anything can become a string in Python. This one won't give you errors. Int, we can't pass it like a, right, or again like Greg or like some other text and have it work. It will just raise an exception for us and we'll get an error in our code. Python will tell us that. So it will need to be a string that is formatted like a valid number. All right. There's another one too, right, which is a little less intuitive to many. The bool function. Bool function, like we've seen with the other ones, also takes its input and tries to convert it to some Boolean value. This is just a little bit weirder, right? Because if we think about it, 6, 9.2, and the string Greg don't readily become true or false, at least as far as my mind can think of. But this doesn't just mean that we can only do this, right? Let me just type it out. So the bool function doesn't only need true or false as correctly cased strings as inputs. It will technically take any type in Python as an input. It will happily do its best. And everything in Python technically has a Boolean equivalent. So for example, this bool of true gives us back true, but bool of tr also gives us back true. Bool of any random garbage I type into a string is also true. So behind the scenes, everything in Python has some sort of Boolean equivalent, which is a little bit weird. But it's true. Generally speaking, pretty much everything you can pass this function in Python is going to give you back true as an output. There are only a few things that will ever give us back false, and it kind of makes sense, right? These will basically represent sort of an absence of data or something. First one we'll look at here is empty string. So empty string gives us back false, which kind of makes sense, right? There's no data in this string, thus it is probably false. Empty single quote string, also false, right? They're the same thing. In terms of values in Python that will give us back false, there are maybe like 7 or 8. Evaluate false. Yikes. We're going to be obviously false itself will come out false. None will evaluate as false. 0 will, the floating point number 0.0 will, empty double quote string, empty single quote string, in addition to a bunch of other empty data types that we haven't learned yet. So we're not really going to mention them now, but empty, dictionary, list, set, and tuple for those who have seen or heard of those before will also come back as false, basically something that doesn't really have data or value yet, right? Those are all false. Everything else is true. Unless you customize it so that it's not the case, I guess. Cool. So we've talked about functions a little bit, right? We've seen print, we've seen float, we've seen type, we've seen bool, we've heard about string and int, right? All of these functions exist, right? Part of what we're trying to do with code is honestly write as little of it as possible for efficiency reasons, right? Not because we're lazy, but maybe both. So we want ideally to make our code reusable, right? We'll learn how to define functions later in this course, but in Python, there are many functions we can just use, right, that they've written, right? We don't have to write the code for the print function that will take a thing and then show it to us in our console. Instead, we can just call print and give it an input and it'll do it for us, right? Same with float, same with int, same with type, right? These all have some predefined functionality that we don't have to write because they're built into the language. So, there's another concept as well called a method. And a method is slightly different than a function, but we're going to look at a few methods right now just to see them. Sort of to end for today, we'll look at a bunch of methods. If we look at functions, right, I'm just writing these, we can just invoke or call these anywhere, right? I type its name, I use parentheses and an input, and we're good to go. Many, right, these, other than their input, they don't really care where or how we call them. Methods are a little different. Methods behave very much like functions and are very similar to, but technically not functions. But they have a lot of interesting, useful functionality. So for example, may end up with one of these data types we've seen that we want to somehow manipulate, right? We're going to start with some string methods. And a method is really, it's a function. I want to say it is a function, but bear with me. It's basically a function that is owned by a particular type, which is a weird concept. But basically, if we create a string, right, let's call this is uppercase. It's a good string. Strings have their own methods, right? These are callable like functions, but they're specifically owned by the string type. They can't be called on integers, floats or bools or whatever. Methods are called with a dot and then their name in parentheses. And they have specific functionality, just like a function might, that can act upon whatever the object to the left of the dot is. This is for functionality that is very specific to this data type, right? Lower function here will take a string, right? Its string to the left of it that it's trying to act upon, and it will convert the whole thing to lowercase, right? So we'll get a copy of this string that is all lowercase. That is not functionality that makes any sense for an integer, right? Or for a float. These just aren't things that can be lowercase, right? The lowercase version of 2 isn't, like, there isn't one. So this is very string specific logic. So it stays as part of the string object, right? This is bundled in with the string itself. There's also, right, there's another method called upper, right? This is lowercase, right? Upper also takes the string to its left, right? The string that owns it, basically, and will return a copy of it that is all uppercase. So these should essentially reverse case. Again, they don't need an input, right? To the left of the dot, that's the string. We don't need an additional input. Same thing here. This is the string. We don't need to put it in both places. We should get this back in, you should get some output correctly in both cases. So ultimately, what this means is we get back, right, this is now lowercase, this is uppercase, becomes a lowercase string. This becomes a fully uppercase string. And these two methods are nice to know, but they're not necessarily, incredibly useful all the time. The point here is really that, methods do exist, right? Not only are there functions built into Python, but there are methods, right? Function-like things that we can call that are more specific to one type, right? Again, these are string methods. We can only call them on strings or from other strings, all right? Cool. So once we have the idea of a method, we can jump into a few other ones that are good to know and maybe a little more useful. There's one particular string method we'll look at. So we'll jump in here. For those of you joining late in the course, by the way, after the course is concluded, so next week, we will have recordings available to you guys of each of the sessions. In the meantime, I have already shared and will reshare a bunch of links for questions or exercises or this actual code that I'm writing as notes, so you can at least start somewhere and give it a shot. You'll also get all of that stuff as a follow-up email afterwards as well if you don't feel like looking through the Zoom chat just in case. You get all those links yet again in a less ephemeral place that you'll have better records of. Anyway, we have another method for strings called a format, and format's a little different. It actually lets you sort of change your strings programmatically as you need to. A few of the exercises may or may not go into some of these methods just so that we can see, right? Get a little practice trying something more than just addition or subtraction or comparison operators. We'll talk about those a little bit later, but don't feel too much pressure from an exercise that suddenly feels really hard because it's something we covered briefly at the end. We'll go into all this stuff in more depth on Thursday as well. Again, everything will make more sense as you get more reps or see more of it. So I'm going to make a quick variable called formatter. I'm going to create a string. So this is just so we can sort of delve a little more into some of the utility built into Python and its library. All right, so we have a string here, right? This is a, and then two curly braces. The format method exists to programmatically add stuff to a string. The way it actually works is format will take however many arguments you give it, and it will replace each pair of curly braces in the string with one of the things you give it, right? Here it will take the first pair of curly braces and replace it with the string. Might be weird sort of spoken, right, to think through, but ultimately we get this output, right? This is a string instead of this is a and then brackets. This can be useful, right, to again inject some sort of functionality into a string. Think, login page or something, right? We need to make this say not hello generic user, but hello Greg, right? Hello someone else's name. To sort of change what our data looks like programmatically for something like this. So this is one example. Technically in Python, there is also another way the formatted string can work that is less explicit. It's not an explicit method call with a dot. It looks like this. Some people love it. Worth seeing it. Just there's two ways to do this. So instead of calling that, we can just prefix our string with a little f. And put in the name of a previously existing variable. If we look at this carefully, we see, right, this is curly braces, this is the name string, same idea, right? We take some value and put it here. Instead of needing the whole method call and all the characters it needs, we will implicitly, right, take some variable and this will come out with the value of whatever we have previously, right? This can be whatever we want in these curly braces. It's the exact same thing. It's just a different syntax. You might see it online a little bit, which is why I'm mentioning it. If you try to use the format method, it's a lot harder to read for a beginner. So don't worry if it's like confusing. You can just use format instead, right? Which takes curly braces, puts a thing there instead of them. But in Python, there's also some other cool logic built in as well that lets us do things like format our input. So for example, we might have a number. right, that might say, let's see, might have a number that's really long and annoying, like 12 point and then all this stuff, right? Again, Python always has some utility under the hood that we can usually use instead of writing all of our own code to say, all right, we don't want all these characters, we really don't care about this much precision. Let's instead round this, right, to a specific decimal place, right? The string format method has a lot of depth, as most function and methods actually do. Most functions and methods built into Python, there's like a million different parameters you can give them if you want to specify how they behave. To the question in the chat, the meaning of F, without the F, this is just a normal string, right? It looks like this. It's just the text. The F before the string, just it's a syntax built into Python that lets us format a string without having to type .format open parenthesis and pass it arguments. It lets us really just do this in the middle of the string. For example, if we wanted to make these two exactly similar to each other, we could say, let's see. So it's just a syntax built in that means these two things are equivalent. Does that make some sense? So basically, instead of having to type this whole thing out, we can get rid of the dot and the method name and the parentheses, and then just have this logic inside our string, have a variable name inside our string. The F is just what tells Python we're doing that. Some people don't like it. It's not super readable, at least unless you've seen a lot of Python. It's kind of annoying. A lot of people otherwise like it because it's brief, quick to type. Capitalize it so it looks the same. Does that kind of make sense? So it just makes these functionally equivalent. Instead of meaning all of these characters, we can just put the F at the beginning of the string. Does that help? I'm assume by silence that means yes, that explanation did help. All right. But we also have function, right, built in to get a little more depth of the format method or the F string, that lets us customize our behavior even further, right? We can format how our output looks. So instead of this, which is nice, but also a lot, built into the method, there is, additional functionality that lets us specify, I actually want this as a float to 1 decimal place. Right, the way the syntax technically works is there's an F for float, and the point number is the number of places, right? 0.3 gives us 3 decimal places. 1 gives us 1, 2 gives us 2, right? We can customize that. Really just, again, as a way to illustrate to you guys, right, that in Python, again, all of this functionality, we can use it, right? It's built in. A lot of these do pretty basic things initially, but there's a lot of depth to everything, right? In the language, functions, methods, whatever. There even functionality for gathering input from our user. So there actually in Python exists a function. And we'll go into some of this stuff, again, a little later in the course too. So like no pressure if, again, methods are getting a little over your head. For now, just know that they exist. There's actually a function called input that will prompt the user for input and let you type in dynamic user input in the console that you can play around with. I introduced this, again, partly one at the end, just to show you guys how much depth there is in Python built in if you want to use it, or if you're interested in playing around with it. And two, specifically input can be a fun function to play around with if you would like to use dynamic input from your users. So I make sure to give you guys that option if you want. Input is actually a function that will, when Python reads my file, right? And that's how Python works, right? It will, as we've seen, it will run my file top to bottom. When I click play, the Python interpreter, when it gets to this line, it will actually wait. It will print this prompt to my terminal and then wait for me to type. I can type whatever I want. An input will actually return whatever I typed, and I can use it further on in my code if I want, right? To get, ask your user for a number, add it to another number, ask your user for two separate numbers, add them together, right? So there's a lot of stuff you could do. It's used primarily for, again, dynamic input from your user, just to make things a little bit, more interactive if you would like. Otherwise, that's going to be all the new material for today. I'm going to briefly jump into the exercise link I shared before, which was for, again, all the exercises live for the Intro to Python course. Once you use this link, which I will re-up in the chat in 1 second, I just need to dig it back up. When you create an account, you should end up on a page that looks suspiciously like this, which is great. There we go. Invites you to what they call a team, but which is functionally like a class or group of people. And you should be able to see these exercises, right? Units 1, 2, 3, and 4. Broadly speaking, unit 1 is today. Unit 2 and part of unit 3, the first half of unit 3 is Thursday, and then the rest will be covered the following Tuesday, and you should be good to go with all the exercises at the end of Tuesday. To attempt the exercises, we can simply jump here, click on an exercise name. We'll start with the first one. They're released in numerical order. I mean, not numeric, vaguely order of difficulty. So I'd start at the top and work your way down. There are only 4 for today. Or if you can get through 4 before Thursday, that would be great. If you can get through part of that, that's still wonderful. If I bring it up, I'll get a UI that looks like this. Right? And you will occasionally get little bits of code that say, like, don't change these 6 lines. Don't change those lines. All right. The exercises are usually going to reference some kind of input from previous, just so that the automatic tests work. All right. Your job is usually going to be write a bunch of prompts in the exercise here, if we so desire. If we really want, if you go to files, there's an instructions file as well. For all of them, there's an instructions markdown file in the file browser up here. It'll open automatically too as like the nice version, not the markdown version, so you can look at it here. And it'll stay open for the duration of your performing the exercise. So this will give you a quick text prompt of what we're doing. All right, you can read through this. You can see all the litany of things the exercise asks you to do. If you write a little bit of code and you feel like seeing if it is correct or if you're on the right track, you can jump to the check mark at the bottom, and there are some tests. Right, these tests will run automatically. Again, don't mess up the provided code because it is what the tests need to function. I can hit the play button here for the tests, and it will tell me what happened. Right here, I get both tests failed because I didn't write anything in the exercise. If you click on the test results, it will actually tell you the difference, right, between the expected output and your output, right? So this is what the exercise got. This is what it expected to see in terms of all these lines of output to the console, and the difference, right, in green, in case you want to see it. Right, so we need 6 more values. which isn't surprising because there are 6 places for me to write some code. The first one here is provided for you for this exercise as a quick example. All the exercises though have tests, so you can feel free to run them occasionally, see what you get. Even if for whatever reason you can't get them to work, you can always submit your exercise anyway. There's a submit button at the top. It'll tell you there's test failures, but you can always click submit anyway if you would like. That primarily will submit the exercise and mean that I can view it. So if you like, if you're on Discord again, you can click submit anyway. If you're stuck, jump onto our Discord server, send me a message. I check it. I mean, very often because I use it for work, obviously, so I'm always on Discord. I just sent the invite again back in the chat. If you join the server, right, you can message. My name on the server is Greg. I look like me. You can send me a message, send me the link to the exercise or just the exercise name and your name. I can find it. I can give you a little feedback if you would like, right? Not many students usually take me up on that, but like, feel free, right? It's a free course, but I will happily give you feedback anyway if you would like it, with a little bit of time, obviously, if I'm busy. But I encourage you to take advantage of it if you can. Yeah, and to again attempt the exercises anyway. Otherwise, that's it. Again, if you have exercise problems or you're not sure how to access them or whatever, please just let me know. And I will do my best to get you up and running. Otherwise, that's it for today's session. Just the data types and some of the operators and a little bit of built-in functionality and some methods. We'll be back on Thursday looking at, starting to look at some other types, some other compound data structures in Python, some of their methods, and just, building on what we learned today. Obviously, the first day is not super fun, can be a little bit convoluted just because there's not much we can do with the code, right? We learned a lot of lines that don't do much useful, which is fair, right? We'll revisit this on Thursday and it will hopefully make a lot more sense. Otherwise, again, we will be back on Thursday, right? 2 days from today at same time, 6 p.m. Eastern. Exact same link as well. I have sent the exercise link, the Discord invite, and the notes I wrote today in the Zoom chat. So I will leave the call open for a little bit in case anyone wants to dig those out of the chat. You will, again, also, everyone who attended, get an email follow-up, including all of those links as well, just so you have them later tonight. So you can reference them there if you want. Otherwise, I want to thank you guys for attending this first day. I hope it was, relatively informative. Again, we'll get into bigger and better things later on Thursday and Tuesday. But for now, thanks for stopping by, and hope to see you guys again on Thursday. Again, hit me up on Discord if you have any questions or anything. Otherwise, enjoy the rest of your night or evening or whatever time it may be, wherever you are, and I'll see you later. Again, I'll leave the call open for like another minute for you to snag stuff out of the chat, and then I'll close it in another like 45 seconds. Otherwise, thanks, folks. See you later.